All right. So nothing's changed since the last time I streamed. I think I'm going to do the exact same thing we did the other day. My hope is by the end of this week, one way or another, that we'll have something done with this. I'm a little concerned that I may be at a place at the end of this week where OCRing live video feed coming off of the Passthrough camera just isn't going to work. At least not for this headset, and then we may have to switch to either waiting for the Quest 4 or switch to a different headset that has a better camera, or wait until there's like an API that allows for just straight up taking still images from the headset. But I'm not going to worry about that right now. I'm going to be optimistic, and I'm going to assume, because I know this logic kind of worked. I was able to actually get, at least briefly, I was able to see that I was able to take 3 frames, merge them together, and at least it seemed like it was better. But I need to reproduce that, confirm that that's true. I know when I jacked it up to 5 or 7 frames, it just didn't, like it, took too long. And so then everything timed out and crashed. I'm going to now go see if I can, one, reproduce that issue. Like, not reproduce the issue. Reproduce it working with 3 frames. See if it's better with 5 or 7. And then as long as it's somewhat better, I think I'll go pull over the other OCR code that I had done on my other machine. And that OCR code, I think that's actually like building out the actual pipeline. So I think actually, so it's, yeah, I think I gotta reorder this. Like, this is my alternate pipeline steps for OCR. I think this will actually work well. So I think we need to detect text in the image and do this just for one, even if we grab multiple. I don't care about that. And then we crop it down to the 2 largest bounding boxes because we just need a block of text. We need a single page. Then dewarp and deskew. I think dewarp and deskew have trouble if it's 2 pages side by side, which would make sense because those 2 pages are going to have different warp and different skew. And so it would get confused, I would expect. So it seemed to only work for single blocks of text, which is probably more performant anyway. Like, things will go a lot faster if we're not dealing with 2 pages of text, but just 1. And then even if I can go down from there. Yeah, so this, I think that's it. So we detect text, we do a bounding box for the clusters for each cluster of text. We crop down to the 2 largest boxes. We dewarp, deskew. Then we do individual image enhancement. We'll do possible multi-image merging, which is what we're doing right now. Yeah. Sorry. I already had that. And then if we do need to do more individual image enhancement, do that after, and then we rescale and we OCR. And I'm cautiously optimistic that if I just blindly follow this path, this will work. So let's get to it. Let's start by trying to reproduce, well, before I do that, here we go. Godot async. Let's get some async code in here so that we can run it in the background. That way, that'll prevent it from crashing, and then hopefully I could do 7, I could do 12 frames, whatever we want to do. And if it takes 2 minutes, it's fine. Let's just see how the quality is. A coroutine has the ability to pause execution before the end of a function, return to its caller, and be resumed where it left off. can be useful where you want to perform a repetitive action but not on every frame. For example, the yield function is used to mark the point in code to pause and return, wait for a signal, then resume code execution without returning from the current function. A wait for a signal. So wait, await signal. So var signal. Why would you call it signal? So we have button. Signal is button.pressed. We'll pause in this sequence of code until the signal is received, but return to the calling function. When the signal arrives, the following code will be executed. Using await to wait for a scene tree timer to finish. So I already have awaits. I've already done awaits. We have an await here. But this is a pause. This is just saying like, hey, stop and... so that the game continues to run whilst the await is waiting for a signal. Passes back control to the controller. The await immediately returns a value that may be ignored such that the calling function code or the game loop continues to run. But if you call a function containing an await, then it becomes a coroutine that can be used with await in the calling function so that the code execution is paused in that calling function. Here's an example. Started, try await. Interesting. So done gets called immediately. This prints started, done, and then after timeout. Because we call this, but because there's an await here, this step is then allowed to continue. But if we await it, then the order changes. Okay, let's try that. In fact, we have this here. But so this would suggest that I should be able to, that this shouldn't freeze up the app. But that's not what I'm observing. That doesn't make any sense. Yield with an internal signal. Godot GD script background task. Can I do a background task? Yeah, async tasks. Can't imagine why, but just in case it would be helpful, here's the node structure. Huh. I have no problem to asynchronously load any resource. That works fine for me, but this example doesn't load anything. Every node is already in the scene tree. It just needs to run. Await the loop. Let's see. Godot async. how to do async functions in Godot. Threading already, but it doesn't do the task passively. Instead, it will try its hardest to complete the task, which is a problem in my case, as that task is very slow. This causes freezing. To do this without getting lag. Tried using await and no difference. Tried doing await plus threading and also no difference. So I don't think so. Thank God it started working. Huh? Thread. Godot GD script thread. A unit of execution in a process can run. It must not have a mutex. Wait to finish. All right. So what can I do here? Because I want this to be 5. Well, let's just try 3 for the moment. No. I can't do that. I need this to work. What is this? I just need a thread example. New thread, thread.start. To start a thread, you need to use the thread start. Thread is short for thread execution. It is a way for a program to divide itself into 2 or more simultaneous running tasks. Threads are a form of concurrent processing. They are used to balance blah, blah, blah. Object instance. So if we did var thread is of type thread equals new thread, and then we'll do thread dot start callable. Okay, so that those documents are wrong. Thread priority. So I should be able to do that. Var thread new thread. Why are you complaining? Expected end of statement after variable declaration. Found an identifier instead. Oh, thread.new. Right. All right, so now in theory, here, let's pop this up to 7. And this should just work. I did revert some code that I had done over here. So I turned this back on just to, because I wanted to get it back to exactly what it was doing before. And I think this is that version. That means I do need to build it though. Let's do that. Okay, so is capturing return. Hopefully because it's in a thread, it's not gonna have a problem with this whole like is capturing thing. We'll see if we get the log statement. So then what we should do is get a frame, a weight, really, what happened to my other code here? Because I had code here I thought for... Oh, because it's... Okay. It would be nice if I could, like, grab a frame, do the enhancement, write that image so that I can see how it performs. Because then that would be cool to see, like, frame by frame. Here's how much it improves quality for 2, 3, 4, 5, 6, right? Like, that'd be cool. But this is fine. I'll accept that as is. Let's give this a moment to do its thing. And then we can test this, see how this is going to work. And let's get our, oh yeah, let me get my other stuff up so that you can see what I see. And let's get this up. Got the permissions. Godot is thinking. Come on. Finish up. And did I do files here? Yeah, this is what I did with files. Here was my last attempt at doing this. And I think it looks like it did improve things, but I can't quite tell. Actually, I probably have in here somewhere. It's probably somewhere in here. A better quality. Like the one that actually worked. But I'm not going to go troll through it that way. Okay, 1, 2, 3. So that's got that. Yeah, let's just do the logging. We'll get the log going. And then where's the book? Okay. Got controller. We've got it reasonably close, but actually let's go slightly further away. So now it's frozen again, which is not supposed to do. I thought the thread would solve that problem. Which means it's probably going to crash, which means I'm not going to be able to get images off of the device if that happens. Darn it. YouTube's complaining about the quality of my stream for some reason. All right, we can tail the log, see if at least something is coming through. One, two, three, four, five, six, seven. Well, At least the thread worked. We know that. Yep, it crashed. Darn. Why would that be? Here, let's go. That's fine. Let's just drag this over. And I probably don't need as much of this, so I can drag that over. Okay. Godot thread. Uses warning to ensure proper cleanup without crashes or deadlocks. It is therefore destroyed. The following conditions must be met. It must not have any mutex objects locked. Remind me again what a mutex is? A binary semaphore for synchronization of multiple threads. Synchronizing threads, eh? Semaphore. A synchronization mechanism used to control access to a shared resource that can be used to synchronize multiple threads. Well, there is a tutorial here. Post, try, wait, fine. Mutex, try lock, unlock. Also look at the thread safe APIs, why not? Threads allow simultaneous execution of code, allows offloading work from the main thread. Godot supports threads and provides many handy functions to use them. If you're using other languages, C#, C++, it may be easier to use the threading classes they support. Yeah, which I'm already doing. I already have a thread set up. But this isn't C++ code I'm looking to run. I'm trying to just run some basic GD script. Before using a built-in class in a thread, read thread safe APIs first to check whether it can be safely used in a thread. This content of this page was not yet updated for Godot 4.4 and may be updated. Okay. Threads are used to balance processing power across CPUs and cores. Godot supports multi-threading, but not in the whole engine. Below is a list of ways multi-threading can be used in different areas of Godot. Global scope. Global scope singletons are all thread safe. Accessing servers from threads is supported. This makes them ideal for code that creates dozens of thousands of instances and servers and controls them from threads. Of course, it requires a bit more code. Scene tree. Interacting with the active scene tree is not thread safe. Make sure you use mutexes when sending data between threads. If you want to call functions from a thread, the call deferred function may be used. Oh, right, I remember call deferred. However, creating scene chunks outside the active tree is fine. This way, parts of a scene can be built or instantiated in a thread, then added to the main thread. So loading a scene, instantiate an enemy, add a weapon to the enemy, and then call deferred to add it to the world. Still, this is only really useful if you have one thread loading data. Attempting to load or create scene chunks from multiple threads may work, but you may risk resources tweaked by the multiple threads, resulting in unexpected behavior. I don't fully understand this. Reading and writing elements from multiple threads is okay, but anything that changes the container size requires locking a mutex. All right. Let's hold on. create a thread, thread.start. Thread function. Oh, okay, thread function is the name of the function. Dot bind wafflecopter. The argument is the bound data passed from start. User data apparently is a thing. Don't know where that came from. And I don't know what wafflecopter is. For portability, exit tree, thread.wait to finish. Your function will then run in a separate thread until it returns. Even if the function has returned already, the thread must collect it. So call thread.wait to finish, which will wait until the thread is done. If not done yet, then properly dispose of it. Okay. So I think one thing I can do here is, let's change this. Let's bring this back. Let's pop this out. And let's do this as a thread. Let's do this as a thread. And then thread.start, let's call it enhance text. But how do I pass? Like, what is user data? Is user data... Oh, print the user data, which is wafflecopter. Got you. So that's the bind. So I could do dot bind frame buffer. And then down here, okay, this is why they're saying drag this up here. This is just fun to experiment with something new anyway. So there's our thread up there. Now I don't need to do anything fancy here. I can just set it to a new thread. I can then do func frame buffer. And then this is going to return void. And then I think I'll do this. Now, production code, I'd want the capturing to, you know, maybe that should get turned off after. But for now, I can trust myself not to do the wrong thing. And who knows, this might invalidate the thread or something like that. Oh, frame buffer's got no static type, which would be an array of images. Exit tree. Oh, that's right. Yeah, sure, fine. That's what it's complaining about. So now maybe this will work. Let's give it a go. Maybe this will be in a background thread now. And this should load faster. Now let's kill that. The logs probably don't show us anything valuable. Yeah, that should build and deploy faster this time, as always. Just take a quick break, drink some water. All right, come on. Work this time. All right, send the permissions. Let's queue up the logs just in case. All right, logs are going. Grab the book. Okay. Hey, it's not frozen. It's still running in the background, hopefully, and that should take as much time as it needs to run and not crash the app. It says looping on frames, aligning frames. Yes, okay. So we did it. We successfully created a background thread. And the aligning frames, that's going to take like 2 minutes. Not that I need to, because I think the same logs are going to show up here. Oh, hey. I forgot to turn this off. So this is... Ooh. Well, actually, no. Oh, this is that permission error that I keep getting. I have no idea why this happens. It doesn't affect the app. But yeah, so we got 1, 2, 3, 4, 5, 6, 7 images. And, you know, it's weird. I can't log milliseconds easily here. But if I do the ADB command, I do get them over here. So you could argue that extra logger setup that I did to log timestamps isn't needed because it's redundant with what's over here. But I don't know. I like it. I like to be able to see the timestamps down here. I shouldn't have to do ADB in order to see these things. But according to this, 34.8, 35.6. So over the course of just under a second, we did 1, 2, 3, 4, 5, 6, 7. Okay, so we grabbed 7 frames in under a second, which is good. I believe, like it should, I would expect it to give us a proper new frame every time. Capture frame, get image. Yeah, we're going to that texture and saying get image. So those frames should be different from each other. And I think this might have been the reason why I wasn't seeing quality before. I added this await recently, because I think if this ran fast enough, I was getting, you know, I was getting those frames within like 1/10 of a second. And I was like, maybe those frames are too similar to each other and it can't actually improve things. So one thing I can try is if this works, then I can turn this down to 5 or something like that. Or ideally turn this down to 3. I would think like 3 frames should be enough. But then if I do that, turn it down to 3, but then up this timeout so that it's 3 still images, but those still images are closer to, you know, a half second to a second apart. So that way they're different enough to actually provide meaningful, enriched data. And this is still running. But it seems like it's still running, so I'm not going to jinx it. Let's see if there's anything new here. Probably not. These logs are probably in sync. I have noticed sometimes that, like, especially if there's an issue with the remote debugging, Godot won't have the new log statements, but I will have them in our ADB logcat. And so tailing the file is sometimes worth it. Also, because then I can see other errors like this stuff. Sweet. Okay, so that issue is solved. While that continues to run, I'll just kill all these things. So yeah, you can create threads, which is probably really useful for me. I probably need a thread because some of what I'm doing is a bit performantly heavy. And even before today, or even before this current issue, I was seeing problems with things would freeze for like a second or like a half second, and it wasn't ideal. Let's see here. Async Godot. Coroutines, await and yield. Async functions. Right. Still running? In theory it is. So I don't know how long it's going to take with 7. 3, it was taking 30 seconds-ish. Well, I actually had that here. I think it did succeed once at doing it with 5 images. But I think it took too long. And I think I was skipping steps. Like I had refactored the code to try to make it more performant. And it was not happy. So then I reverted that code because I was like, let me get back to the version that works and then let's solve this threading issue. And then once it works, I can commit that code, back that code up, and then we can try refactoring and get the same quality output at a faster speed. Why is aligning frames taking so long? It should be done by now, I would think. Let's go look in the code. Aligning frames. So it's on this step here. I could add a log statement here. So we could do aligning frame plus I dot is like 2 str no how do I do this? I thought I was doing it somewhere else. Gotcha. There we go. And hey, it finished. Okay, but how long did that take? Interesting. Okay, caller thread can't call this function in this node. Use call deferred or call thread group instead. So that would be, and that, yeah, so this is an example of, that's annoying. This is an example of an error that, well, I probably did get here, but I have to go to debug errors. Yeah. So I wonder if I can do cannot find member. What if I do emit dot call deferred? Maybe you're allowed to do that. All right, and then what else do we got? Okay, averaging the frames, enhancing, done. And then another permission error for reasons, and then I killed out. Okay, let's, before we do anything else, let's just grab those files so I don't lose them. Yes. Good. And then we can probably kill it. Let me get just have my 4 commands queued up. There we go. Now, how long did that take, by the way? So we're like 38 to 39, 40, 41, 42, 43. So over 5 minutes. Cannot get return value of call to emit because it returns void. Okay, so there is no whatever. I mean, again, this is something that I know, again, when I do the production version of this code, what I'll probably do is the same thing I did for OCR, when I do the OCR step, I call this, it returns immediately. And when this function's done in the C++ code, it emits a signal. And then I just have a catch somewhere to then handle the results from that. So that's fine. Oh, darn, no. This is frustrating. I don't think I would have gotten any images. This is what I ran just now, right? And all we have is the original. Okay, so Godot emit signal from thread. Can signals be used safely in multi-threaded code? Got you. Okay. Godot call deferred. Okay, so I had used call deferred before as like a property, like a method available. So this is saying we should use call deferred string method name. Oh, this will be calling deferred a function. That's not what I want. Emit signal name is exactly equivalent to emitting a signal that was connected with flags. Huh. Thread and signal question. Because of calling a thread. Okay, fine. Emit signal. And that's going to be this. But I don't know if any of these are going to work. It likes that. But so call deferred and then ... calls the method on the object during the idle time. Always return null. This method supports a variable number of arguments, so parameters can be passed as a comma-separated list. Got you. So you can just call rotate and then pass the arguments to rotate. Okay, so that should work then. To test this, since we're now in a world of hurt, let's just do it on 2. And hopefully it's reasonably fast, and then we'll scale it up from there once we know that it's working. Because I don't want to wait 5 minutes only to find out there's another bug. 1, 2, 3, 4. We'll have that queued up. Let's clear that. Drag these up a little bit so I can see just at least the corner of that box. When that box disappears, I'll know it's ready. Okay. There we go. Let's get the headset on, and then continue. Might as well hit the logger and tail it for readability purposes. Okay, and triggered. Again, we still get a freezing effect there for a half second, but can always deal with that later. Aligning frames is running. And again, this should take, yeah, exactly. That should take only a few seconds. So now we're back. It is now gonna OCR the results, which, fine. Like, I'm not really expecting quality there, so I'm not gonna worry about it. I'll kill the log. I don't need that anymore. There we go. Similarity of 0.27, which is low, but I'm still working out that quality metric that I'm doing. I could probably take a higher quality image of that same page and then OCR that and then see how close I'm getting to that level of quality. Yeah. All right. Let's, what was it? 1, 2, 3, 4. Yeah, grab the files. And did that work? Did we actually get the files this time? We did. So I probably need to try to save off an extra image. Okay, well, so that's the image we took, which honestly isn't that great a quality. What I should see, hopefully, actually, is even though it's black and white, that the quality has gone up a bit. And I can see there's been a little blurring of artifacts, so it did something. I don't know what it did that's any good. Yeah, I can see like there's 2 O's here, which basically means like my hand, I guess, was moving while I took the picture, or the headset was moving. So that hurt the quality. But we're doing frame averaging, so that worked, which means we should be able to step it up and see better quality. So if I go to 3 now, I may actually see reasonable quality this time. Maybe. With a steady enough hand. This could be an argument for, you know, if I am seeing that kind of drift, that would be an argument for turning it down, right? To see, like, with a steady hand, is it fine? But if I, instead of waiting 1/10 of a second, what if I waited 1/20 of a second before grabbing a still? Because we just need frames that are next to each other, is really what we need. If we are able to grab 7 images in a second, and I don't think the camera feed is 24 frames per second. I think it should be at least 60. Then, if that's true, what does that mean? I mean, it might even be more than 60. I think it's set to 60 right now. So if the camera feed is 60 FPS, I wonder if I can mess with that. That might help with performance on the headset. Either way, even at 24 frames per second, yeah, I should be able to turn it down to 1/20th of a second then, and still get adjacent frames, and not have to worry about getting duplicate frames. Okay. And that should, in theory, make this perform even better. So hopefully we're now in the tuning phase of this, like, actually working. And now we're just tuning stuff. Okay, this time I'm going to try to just hold it a little bit steady. All right. this is probably still running. No, I killed that. Yeah, I don't need to tail those anymore. All right, aligning's still happening. And then it finished. And oh, by the way, when it's measuring the results, I could probably turn off the Haka results until I get something slightly better. Because the results it's comparing against are garbage results. I didn't actually sit down yet and get the proper OCR for the page that's accurate. So even though this says 0.29, like 0.29 of what? It's comparing it to garbage, so I don't really care about it. I do want to fix that though and get to a place where, yeah, I'm actually like, yeah, if I can OCR, well, yeah. Ideally, like an automated test that I can run against. All right. Let's see what we got. In fact, I'll probably just delete a bunch of these. Well, let's just see how the latest one is, and then we'll delete a bunch of those. Okay, and then... In fact, ooh, why is this so slow? If I drag that there and bring this here, and then we can then zoom in. Let's use the upper left-hand corner. I'm gonna kind of say it's slightly better. I mean, look at this Y here. WH, we know that's a Y. Like here's Y, but that Y kind of got lost here on this one still image. But here, that Y is distinct. So I think it actually helped. And the question is, like, is there an order of operations thing here? Should I do some pre-processing to denoise the images before merging them? Or probably my theory would be you don't really know initially what's noise and what's not noise. And by doing this frame averaging over multiple frames, that alone should reduce some of the noise, because then we're figuring out slowly what's noise and what's not noise. All right, I'm cautiously optimistic. Let's crank it to 5. I won't mess with this yet. Let's get it up to like 7. I've been told just from research, 5 or 7's probably all you need. Like if you're doing any more than that, you're wasting time. Like it's not really going to improve things much more. Which I guess like 5 frames is enough for like redundancy. If you assume 1 or 2 of the frames is bad. And especially if you've got aggressive thresholding for whether or not you trust a given frame, then you could throw out 1 or 2 frames, and then you have like 3 solid good frames, and you merge their data. That should be enough. I'll be really excited if this works, because this, like, I was starting to feel like maybe the project here was going to be in jeopardy. If this works, I am going to be elated. Even if it just works a little bit, my hope would be I get compounding benefits with some of the other techniques I'm doing with OpenCV to improve things. Okay, let's do that, and then triggered. And that's running, so now we're at 5. That's gonna take 2 minutes, maybe? I do want better logging, so let me rebuild in a second. let's see. The second this finishes, I'm going to do that rebuild. Here, let me even get queued up for it. And all it did was add this extra log statement, but I do want to see which frame we're aligning. Oh, there we go. And now that we have those results, I don't think this would affect anything if I was doing a build while it's already running, because I don't think it would hot swap the DLLs or anything. Let's see. Come on. Cool. And then that's done. Get the files and kill it. Come on, here we go. Hopefully this time we see noticeable improvement, although I am seeing some dicey artifacts. So if we go upper left, you can already see like we've got like an extra shadow 82 there. So something didn't quite go right. But was there a spot that like, ooh, no, that's not what I wanted you to do. Was there a spot that like it did pretty well? Maybe it was over here. That looks pretty solid over there. So seeding this. Oh yeah, look at that. Communications is beautiful. Okay, so this works. But this actually changes things. So now I'm realizing it's interesting that like we have one part here which is done really well and this part is not at all. So how did it fail to align properly? That's interesting. Two thoughts I have. So one would be maybe I change up the pipeline order. And so then step one would be to grab just one of the images, not all 7 or 5. Just grab one of them. Figure out where like the text is. Do text detection. Do a bounding box around the clusters of text. It may detect other text in the background on the sides, but if we do clustering, we should have 2 clear clusters of text. And then have it crop those out. So isolate just to this one page here. Then do dewarp, deskew. And then literally like do it for one image, but literally apply the same exact transformation for all the other images. Don't recompute them, just literally apply the same cropping and everything to those other images. And then do this frame merging layering technique. And if we did that, I wonder if that would solve this, or again, like if there was movement, any movement at all, then maybe it would struggle to. I don't know. That's curious. So one thing I want to try is let's drop this down to 0.05 and let's bump this up to 7. We did finish our build, right? Yeah, so now we should have better logging so we can at least see progress as it's happening. This might take 5 minutes to run, to be warned. And because I dropped down that time, that wait time in between grabbing stills, we shouldn't have as much drift. And we may have like super high quality now, like really good, or at least as best quality as we can. I may do some quick research to see what is the FPS. I mean, I guess I could do it with trial and error, right? We could keep dropping down that await to a lower and lower number. Because I don't want to wait a second anyway. I don't want to take a second to grab images. Like, every second matters for this operation I'm doing. So if I can do it in a quarter of a second, grab all the stills we need, we should do it. I'm not going to grab the logs. Let's just do... Keep it simple. Because we're not getting any errors, so there's nothing to see in the logs right now anyway. Come on, here we go. Click. I'm actually feeling... I'm glad I got it back. I'm feeling very optimistic. I think the mistake I made the other day was I immediately started refactoring the code to make it more performant, which I think I can do, but that immediately then had things not working well again. All right, let's do this. Yeah, there we go. Aligning frame. Well, that's a terrible log statement. We can't go with that. We need a space in there. Aligning frame 2, 3. So interesting that it's pretty fast. I wonder if it's going to slow down as we get to frame 4, 5. You would think it would be done now. Well, that would be about 30 seconds, which would match what I saw before. I wonder if there's like a exponential curve here. So like frame 6 and 7 are going to literally take forever. Note that frame 0 doesn't get aligned because frame 0 is the frame that's being used for the alignment, which what I probably should do is pick an odd number. And like frame 3, if I do 3 frames, it's the middle frame that the other 2 should align themselves to. So we're averaging starting from the middle. That's probably what I should do. Pop out that middle frame. And that may boost quality a bit. There we go. There's frame 5. Yeah, this will be interesting to see down here, like where the, like is there an exponential curve happening where like every additional frame takes even longer than the frame before? I mean, right now between 4 and 5, what was that? 50. That was a minute. But then 5 to 6 was. So maybe it's a frame quality thing. Maybe. Depending on how much work it has to do to adjust that frame, maybe that increases the work. In any case, it should almost be done now. At least it gave us something to look at and pass the time. Come on, come on, come on, come on. Finish up. Let's do this. I want to see it. I want to see it. I want to feel good about it, and I want to move on. Like I've spent the past couple of months, and I'm a back-end dev by history. Like most of the projects I've worked on in my career have been back-end. So don't get me wrong. I love playing around in OCR and Tesseract and C++, but I really want to get back to just straight up Godot, and it would be very nice if I could start moving on to like a visual functioning app that I'm then just making small improvements on top of instead of trying to get the base infrastructure of this thing working. In theory, this is the last of those steps. This is the last step that is, like after this, I could hopefully just spend a solid week getting some bare bones demoable stuff into the Godot VR experience. And then I could, if I wanted to, put out an alpha build of this thing for people to experiment with. It's interesting that, like, I wonder if the image is terrible. But we did get a bunch of content over here, so I wonder if page 2 is very well done, but page 1 got messed up. I wonder if it does like a sub-sampling of things before it does the merging. Anyway, in theory, I could put out an alpha build and then just start iterating on it until it's an actual, like, enjoyable experience, not just a functional one. Right now, I'm just still trying to make it functional. All right, grab those files and kill the app. Let's open that. I think we have a similar issue to last time. Yeah, we do. So it's hit or miss. It seemed like it aligned them well. I wonder. Why is that back there like that? That says to me, by seeing that little bit of a shadow. I mean, we got some crispness here. Things got a little crisper. But there's a little bit of shadowing here, and I wonder, is that right there from this up here? Okay. Let's try some improvements then. Well, what do I say here? I don't want to go too crazy just yet. How did we do? I didn't capture the log, so I can't see the microseconds. But I'd be curious to see, like, was this too tight? Get image returns an image that is a copy of data from a new image is created each time. Note, this will return null if this texture is invalid. Okay, well, I think I've seen it working. So if that's the case, let's commit the code. I hate all these imports that are here. Fine, git add add-ons. Git add. I don't really want to do this. Git add terrain. All right, let me just do a checkpoint commit. Git add icon star. Let's get rid of these imports. They're distracting me and they're annoying me. Any others? Good icon. Fine. Git commit -m. Re-importing things for reasons. I don't know why they all re-imported, but they did. All right. Here we are. Oh, camera enhancer test got deleted. Oh, but this is the old. Well, no. That. Oh, yeah. Okay. Fine. Git add source. Git add. Fine. Star.gd. Git add bin. Git add sconstruct. This action map keeps changing and it keeps breaking the hands, which is really annoying. So I'm not going to check that in. Okay. Commit -m. Merging frames seems to work. Question mark. All right, now we're backed up. So if I do something dumb, we can always roll back. So the first dumb thing I want to do, let's see here. Yeah, so I wanted to do this thing where, for whatever reason, we were doing like black and, so if we look here, if we look in align frames, like, hey, why is this so slow? Like, what's the slowness here? So if we align image, the first thing we do is convert it to grayscale, which I don't know how long that takes, but like we're doing that every single time. And we do it, by the way, for the reference image. Convert it to grayscale, which means, if nothing else, the reference image gets converted to grayscale 5 times, 7 times, right? Like extra times for no reason. Probably not an issue. But that was one thing to try to pull out. And I pulled that out and then things seemed to stop working, or maybe it was just an illusion. I'm not sure. And so my thought was, well, why aren't we doing that here then, right? If frame size is less than 2, frames 0. Okay, so we should pop the middle frame off. Let's see here. Where do I have? Do I have? Oh, here we go. And what was this? I was back here on this conversation. Yeah, I was using 2 different AIs to build this. In fact, Claude's version, which normally Claude is better at coding, was not as good as ChatGPT's, which is surprising to me. Let me kill this for now, because I need the headset to not... hello, where are you? Okay. I need the headset to not lose power if I'm doing a longer stream. So let me plug that in over here so I don't get like a warning in the next like 30 minutes or something about it being low on battery. All right, let's do a new chat. So I have a C++ method where with this signature. I am doing, merging frames from that list. Actually, I don't even care about this. Fine. I am doing an... So, what am I trying to say? Right now, the first frame in the list is used as the template that all the others get aligned to. I would prefer to use the middle image in the list, since these are frames pulled from a video feed in sequence. And so the middle frame should be more average. If the list has an even number of elements, that's fine. We can do floor or ceiling to get close to the middle. How would I pop that middle element from the list in C++? That's really what I'm asking, because my C++ is a bit rusty, so I'd rather it just tell me how do I properly pop it out. To get the middle of the element, you can calculate the middle index and access it directly. Here's how you can do that. Yeah. So that's the middle index. So middle index, if you want to be more explicit about the middle calculation. So for odd size, exactly middle. For even size, it'll be second of the two middle elements, the ceiling. Or, that's wrong. This gives the floor, this gives the ceiling. Sure. I mean, I'm always going to do odd numbers, I think. Doesn't have a pop method like some containers, but since you're just using it as a template for alignment, you don't need to remove it from the array. Just access it directly by index. The middle frame will still be available in the array for processing along with the other frames. If for some reason you need to actually remove the middle element and work with a modified array, you need to create a new array or convert to a different container type. Do I need to do that? Let's see here. So this is operating on all of them. It's actually building a new list, by the way. So we're already building a list of frames that are CV mat. And then we were getting the first one and then pushing it back from there. And then we were getting the 0th one. Okay, I could probably do a check here. Do I want to? I could do something tricky where I go and secretly grab the middle one. This feels ugly. I'd say, I do in fact want to remove it from the list. How would I do that? Without the middle element, here are a couple of approaches. Create a new typed array. Convert to for easier manipulation. Was I already doing that? Yeah, we already had a standard vector of frames. So we're already doing this step, actually. So we get the middle index, we get that one, and then we remove it. Oh, okay. So I'm going with option 2, std vector, since I was actually already doing that anyway in my existing code. How can we improve that method to flexibly handle odd versus even lengths in the array? Gives you flexible control over how to handle odd versus even lengths. Okay, so we check for size, we return immediately. If not, was already doing that. We push back, which we were already doing on a list of frames. So this is a ref image. No, so this is, I'm not doing ref image, I'm doing CV mat. So we're doing a conversion on the pushback for those. Okay, so here's our middle index calculation. Here's our short circuit. So I'll add this. We're going to do option A. And we'll just call that floor. Get rid of all this. There we go. So now we have our middle index. Yeah, so this is size modulo 2. So what is the, if we take size and we divide it by 2, what's the remainder? If the remainder is 0, when we divide something by 2, we know we have an even number. Technically, I wonder if they, does C++ have a notion of truthy and falsy? Because if it does, you could just do like, hey, look, if size mod 2, you know, is true, true would be not 0, then we're dealing with odd. Otherwise, it's false, but this is more explicit anyway. Otherwise, if size mod 2 results in 0, that means we were able to evenly slice it in half, which means it's the even version. In which case, then we take the size, we divide it by 2. Well, yeah. We would take the size, we would divide it by 2. That doesn't make sense. Hold on. Because if let's say there's 5 elements. Five elements divided by 2 would be 2.5. This logic might be backward. Ceiling. That doesn't seem right to me. This is why you got to double check AIs, because they will do dumb things like this. Either way, let's do I don't need parameters. That's fine. So this is going to hate this because it's going to say that's CV mat. There we go. So now we have our template frame, which means we can get rid of our ugliness here because we removed it from frames. So we can go back to 0. And now we can do our template frame. Now we have like a little bit more readable code. And this might actually improve quality again, because if we're getting the middle frame, if we're doing 5, it's the third one, the middle one, will be the reference. So right now we're pushing this back on by itself. And then we're going to align all of those and put... So we are kind of doing it out of order a little bit. But it's fine. We're doing the align step. So they all should be aligned, and then we just average them. The averaging is pretty fast. Okay, so mod 2. If we get a remainder of 1. Let me just call the AI out on its nonsense. I think I see an issue here. If we had a length of 5, then would be true. We would then do which would get us 2.5. We would then try to grab that index from the list, which would fail. Correct? Or am I missing something? Let's see. You're absolutely right to this question, to question this. But actually it works correctly. The key detail you're missing. Frame size returns an integer. I love C++. And when you do integer division with divide, it automatically truncates, floors the result. So with frame size divide 2. 5 divided by 2 is 2, not 2.5. Integer division automatically discards the fractional part. Let me trace through a few examples to make this clear. Yep, so index 2. Oh, right, it'll floor it. So index 2 is the exact middle, because it's not the 0th element in the list. Good explanation. Okay, with floor strategy, so we divide by 2, so 4 divide 2 minus 1. 2 minus 1 is 1. So if there's 4 elements, then it's gonna be 0, 1, 2, 3. So the 1th element will be the second one in, which is what we want. Yeah, those are the 2 middle elements. Yeah. Okay. I would complement the AI right now, but that would use up more of my free tier, and I don't want to do that unnecessarily. All right, so then in theory this works then. Cool, let's give it a go. Let's see what happens here. And let's get the headset back online. Quest up. Kick off that second build. Is that done? No, still thinking. Let's kick it off. Now we wait. While we wait, let me go back and I care about the 18th. Do I care about this at all? Why did that do that? I don't think I care about this. No, I was still messing with issues. So let's just kill all the 16th. We'll keep two of them from the 16th. Why not? The start and the end. Permissions. And let's see how we did. In theory, if the aligning is performantly intense when the images don't align, this should boost speed, potentially. Oops, I didn't hit continue. Okay. Let's let that run. Yeah, aligning the frames. What was our speed? We cleared out the logs, so we lost them. Well, anecdotally, we can see the speed. All right, we're at 7 images, so aligning frames. And then aligning frame 0. That took 12-ish seconds, then another 12-ish seconds, and then another like 12 seconds, 10 seconds, another 13, 14 seconds. So about 12 seconds each per alignment. So far, it feels like it's faster. I think it's slightly faster. Should be faster and more accurate would be nice. So I don't know what algorithm it's using. I'll have to go look into that to see like how is it doing the alignment. And again, if I chop the image in half and I just cluster based on left, right, and then do this alignment per page, that might even be even faster, which would be the hope. Well, now it's like kind of going slow. Oh, now it finished. 1, 2, 3, 4, 5, 6. It's that sixth one, which took, like a whole minute. I wonder if there's like an issue there. Yeah, we'll give this a moment to see what it comes back with. Obviously, this entire operation takes entirely too long to run. I do have a number. Yeah, again, I have a number of thoughts on how we can boost things. Anecdotally, visually, more text came back, so that's promising. How's it look? I would like to get different images per step. Would be nice. Go, and then, okay, let's take a step back and just look at things. Generally, it looks well aligned. So I will compliment it on that. Let's zoom in super tight on like the 82. So this is blurred up here. I'd even argue like this is better quality. But if we go over here, now the quality's better. Again, communications is readable, process is expensive. Like I can't even read this word here, but I can kind of read it there. So it's definitely improving things. Okay. I'm gonna call this a success and hope that the next step of things is gonna improve things. So I'm gonna actually bring this up. Let's do old there. So let's detect text, bounding box around each cluster of text, crop for 2 largest B boxes with a little bit of padding added. And then I don't know about D-warp D-skew. Let's bring that down here. My current theory, I'll just go off with current theory, is this. So we would get the bounding box, we'd crop, then we would merge, blend multiple frames. Not if needed. We're going to do it. So my theory would be if we've cropped them all the same way, and then we blend them, that's gonna boost things quite a bit. Might even reduce a little bit of noise as a part of it. And then we then maybe do some other, we do some other denoising and some other basic improvements. And then we dewarp, deskew. Maybe even, I'm gonna even go ahead and say, probably even this. So we dewarp, deskew after merging, because then we have like good information at that point. Because I think the merging frames is something you want to do when the content's a bit more raw. Dewarp, deskew probably as well, so it can detect like the range under which to dewarp, deskew. And then at that point we should have pretty flat text that is pretty well aligned. And then we could do some basic image enhancing, then do a little bit of rescaling, and then we OCR. And somewhere in there, we're gonna go to grayscale anyway. I think that's gonna happen no matter what we choose. It's like one of these steps is gonna require grayscale. But that's fine, that's what OCR wants. And then we could leave it up to OCR's binarization. Probably not. Let's say this is denoise what do we have? Oh, yeah, denoise, contrast, etc. We would probably then do custom binarization, I think. Because I think once we've done that, once we've dewarped and deskewed, I haven't seen this yet, but once we've dewarped, deskewed, and we've already cropped it down to where we need it to be, then when we do the binarization, like it should be, in fact, we may even be able to skip these steps here. Because the binarization, if it's a good threshold, they actually just like rip out all the noise anyway. And then we rescale it to where we need it to be like 30 pixels at 300 dpi or whatever. And then we OCR. Turn off binarization and other steps. It actually makes me wonder, when OCR has been slow for me before, I wonder how much of that is doing some of these binarization kind of steps. This would be the pipeline. And then if this works end to end, then we switch gears to, can we make it fast? And the easiest way to make it fast would be, okay, we'll crop to the two largest bounding boxes, which that would get us that would get us like page 1, page 2, right? But then if we then took page 1 and said, well, we're only going to operate on page 1 for the moment because the user just turned the page, let's just presume. In theory, we would then probably dewarp the whole thing just to fix that. But then take like the top third and crop that again. And so once we've done that, like these steps will be as fast as they can be, and we would be limited to whatever the speed is there. But after that, we could then, crop down to like the top third. And so then again, we're seeing this step being slow right now. That step should be a lot faster because we should be dealing with 10% of the image, because we are already ripping out the whole background. We're cutting down to like just this size here, which even here, if we zoom all the way out, like that is already a quarter or less of the image. And then if we cut down from there, we may only be dealing with like less than 10%. So that should be a 10x speed boost. This should go 10x faster. And then we de-warp, de-skew. And then by the time we get to this step, like OCR may only be like a second to run. So that's my hope anyway, that I can take all this. The first version of it's going to be reasonably slow. But then when I do those speed boosts, we hopefully, fingers crossed, can get it down to like 10 seconds or less. That would be my hope. All right, I'll take a drink. My coffee's getting cold. I haven't been drinking it quick enough. All right, so that's that. Let's move on to the next step then. Let's kill this. I think we go into code mode. 7. Let's go down to 3. We want it to be fast while we work on this for now. Also, oh yeah, here's all that triggering a signal. Call deferred. Emit signal thread. Sure. Let's go meta quest 3 camera FPS. Use advanced camera settings. Huh? What is that? Best views, huh? Ban. Advanced camera settings are available on MetaQuest to allow you to set the quality and format of video recordings and photos. Yeah, I don't want that. Decreases field of view. I'm okay with that. Aspect ratio. Choose a default format and resolution of photos. Frame rate. Choose a default frame rate for videos. Higher frame rates are more likely to detract from app performance. MetaQuest 2 only supports up to 30 FPS. But that's Quest 2. MetaQuest Passthrough camera API. Site is meta.com. Here we are. Pass-through camera API overview, Android camera API. So in theory, this is supposed to implement everything that's available here. I wonder if I'm barking up the wrong tree here. Like, is it possible? Godot still image from webcam. So this is camera server. But I don't want to stream. I keep assuming that this is stream option only. Different cameras accessible to Godot. Keeps track of different cameras. Note. But see, that's the thing. It's a camera feed. I don't want a feed. Why is there no, like, still image? That's the thing I keep wondering about. But therein lies the problem also. If I try to search for camera, I'm going to get all this stuff about. like camera 2D, camera 3D. Yeah, there's 10 different things here. XR camera. Camera attributes, okay. Camera attributes, physical, practical. I don't know what those are. Okay. Camera texture, yeah. Camera feed, camera server. But I don't want to feed. Okay. I keep barking up this tree, and every time it ends up being a waste of time. Let's take a look. Controls camera-specific attributes such as depth of field and exposure overview. When used in a world environment, yeah, okay, this is not. I don't think this is what I want. This is not the camera that I'm looking for. And then set rendering settings based on physically based camera settings. Yeah, I don't think none of this is related to actual cameras. So let's see here. Blah, blah, blah. Quest 33S, camera permission. Camera 2 is implemented in modern Android phones. Image capture. Capture camera data. Yeah, I mean, this is the other fear I've had is, what if I was wasting my energy on the wrong thing? Instead of trying to improve camera feed still images, is it possible that Meta exposed this? And the issue I'm having is just Godot didn't implement it. In which case, should I have been contributing back to Godot by adding still image capability? Yeah, fine-grained control over camera settings. So Meta is at least saying, in theory, that they're exposing everything available from here. Which, oh, by the way, I don't want the video feed running all the time if it's going to eat up extra processing power. Literally, I just want to say, like, hey, every few seconds or so, go grab a still image, and then I'll figure out what to do with it. Okay. Performance. Here's what we're looking for. Latency is around 40 to 60 milliseconds. Image capture latency. Okay. Data rate is 30 hertz. So 30 frames per second. Okay. So what is 1 divided by 30? So if I grab the still image every 0.03, that would get so in theory I should be able to do that. Wait for that much time. And there's probably some overhead to some of the logic, like pushing it onto the list. But to be safe, if I do that, this means at best, I will get every single frame. In reality, I'll probably get like every other frame is likely what will happen. Or it's possible, like, sometimes I'll get every frame, and then sometimes I'll get every other frame. In either case, this is probably more optimal. Can I do inline comments like that? I can. Okay. Meta says 30 hertz. And 30 hertz is going to be 30 frames per second. All right, so for all these reasons, I am going to move on because I don't want to waste a bunch of time optimizing this code only to find out later that, one, what I'm doing is obviously going to be slower, and I'd be better off just waiting for API access where I can just grab still images directly and just tell it to grab still images. And if I am going to put my energy into that further, I'd be better off adding still image support. Well, this says image capture. This is the thing. This could be implying video. This doesn't necessarily mean still images. But they're also saying fine-grained control. So anyway, my point being, if I'm going to do any more energy on this aspect of the problem with OpenCV, I'd probably be better off investigating to see, can I get still images from Meta? If so, can I add that support to Godot, contribute back to Godot so that that feature's there, and then maybe that is the thing that I need so that I can actually get like high-quality images off the camera. Let me take a quick look at this though. Use stream use cases for better performance. Stream use cases are a way to improve the performance of camera 2 capture sessions. They give the hardware device more information to tune parameters, which provides a better camera experience for your specific task. You specify a particular right. Still capture. That would be the thing I would want to do. Right. Okay, I am not going to look at this at all right now. I got the answer I wanted. What I am going to do now is, go back to, so I guess to do this, I got to go start pulling in code from my other computer. And did I push that up? That's from 2 weeks ago. This might not have the latest code. It might actually, because I have this works well for all the books. I've got this test scenario up, which would be can I see it? Yeah. Yeah, so this so it's going to be this kind of thing. Yeah, so this is the version that I know works right now that I'd want to improve. And this is on a high quality book that's held flat. There's the raw text result from the OCR. And then Right, okay. Yeah. So this would be the right code. If I... Yeah, this is slow smart OCR. That version of that file. Right, and then we're doing... Okay, so I do have the code. I could get started on this right now, pulling this over. And that's corner detection. I didn't like this because although it worked, it was trying to detect corners, which is not what I want. So this is detect tech region. So let's look this up. OpenCV. The maximally stable extremal regions key point detector. Works by applying a series of thresholds, one for each of the grayscale levels. Yeah. Star. What's star? What's it used to detect? Blob-like structures and images. These regions are assumed to be small or relatively same pixel intensity and surrounded by contrasting pixels. Similar to star, the Miser key point detector labels few regions, only 151, as key points compared to other blob detectors and corner detectors detailed in this module. As you can see from the example image below, most of these regions correspond to parts of the image where the pixel intensity distribution is relatively consistent and similar. Okay. This is just the API doc. What if okay, I have this code, but I have found it interesting to test different techniques with different AIs. And then oftentimes what you'll find is like they'll do similar things but in a different way, and there'll be issues with both. And in theory, like then you'll end up with a better approach. So let's see here. Where am I calling this from? So we're passing in an image actually. Detect book corners. Converts to grayscale. Minimum 10% of image area. Okay. Text corners. If it is a valid rectangle, which it would never be. If no good rectangle found, use edge-based detection. Oh, this is the fallback. I wonder how often I was falling back to this. I think hopefully never. I may have improved this code and just didn't push it up yet, which is a mistake on my part, as I should always be pushing code. Detect regions, regions found. Found length regions. I think this ends up being a big number because I think, hold on. If debug folder, image copy, for regions and regions, hull, polygon, Miser regions. So if we go to this, it's this one. Right, that's the one we were talking about. So what we're seeing here with the green is the MSER regions that it found. Okay. If we go back up here then. So this is doing a really good job, is what I found. The question is how fast is it? But let's ignore again. Let's ignore speed for the moment. Let's go on quality. If it's accurate, and we then end up with a bucket of regions, which oftentimes is a lot of them, right? Let's now chat with an AI. I am using OpenCV to detect text in an image. All the images I am working with are books. Using Mizir, yeah, however it's pronounced. I am doing a good job of finding all the text as well as some noise. I would like to isolate the 2 pages of text and filter out the noise sections, that the noise regions found with Mizir. I end up with like 1,500 regions that it's finding. I'd like to cluster those regions by proximity. So I can put a bounding box around the 2 largest regions and crop those out. Is this a good strategy for solving this problem? Are there other approaches that might be better? At a high level, what would be the steps, tools in OpenCV to accomplish this? Please stay high level, do not write code. Let's see here. Your strategy is solid and well suited for book page detection. Clustering Mizir regions by proximity to identify the 2 main, I think it's writing text now, code now. To identify the 2 main text blocks is a practical approach that should work well for most book layouts. Good choice for text as it's robust to lighting variation. Okay. And I had seen this. This does seem to perform really well, even with garbage images pulled off the video feed from the VR headset. Proximity clustering, smart way to group scattered character regions into page level blocks. Reasonable assumption that the 2 biggest clusters are your pages. Bounding box extraction, clean way to crop the final regions. Yeah, see, I didn't ask for code. Okay. Pre-process Mizir results. Filter regions by area, aspect ratio, or solidity to reduce noise. Filter regions by area, aspect ratio, region for region in regions if min area is less than contour area region is less than max area. Okay. I may want to skip this step because I don't know what the min and max are going to be. I could do it like a mean of them, an average of them, because well, that might not necessarily work. And the reason it might not work is because if a book is held naturally, some characters, like up here, these characters might be larger than ones down here if the book is skewed. And so if I do something like that, yeah, my instinct is that this won't help. I mean, it could, okay. What I could do is hold the book really close to the camera. Also, yeah, each book is going to have different font sizes. Yeah, there's really... Unless you're detecting it dynamically. I mean, you could take the regions and assume... If you assume 90% of them are text from the book, and that the bottom 10% may or may not be text from the book or noise in the background, then you could take that 90%, like lob off the bottom 5, like the bottom 5 and the top 5%, and then do a mean averaging or something of that to figure out like a reasonable min and max. Add some padding around them, drop this down a little bit, drop this up a little bit. Then this would probably work for filtering out all that noise. But that feels like extra work for no reason. Extract centroids. Centers. So grabbing the center point of each region. Use k-means clustering. I've heard of k-means. scikit-learn. Final bounding box. Okay. Morphological operations. Apply closing dilation to connect nearby text regions before contour detection. You know, there is some morphological code here that I don't think I tested. I think it was disabled. That almost certainly is there and just not pushed up. Projection profiles. Analyze horizontal, vertical pixel intensity projections to find text columns. Projection profiles. So this is what? Like draw horizontal lines on the page effectively. Like scan horizontally across the page. And if you find like a lot of dark pixels in one line but not in the other, that would tell you that that's a line of text, whereas the line that doesn't is a blank space in between those lines. Same thing vertically. And if you did that, I could see this being faster. Because conceptually, assuming that's what this is, I should just keep this image up. Conceptually, if you started drawing vertical lines here, you could say, hey, look, do that from left to right until you hit a white spot, right? Until you see a significant dip in dark color, right? And we've dropped down. And then keep going until you get a new spike in dark pixels, which would mean the beginning here. And that would tell you that's the start. And then you would keep going until you'd see a drop off, a noticeable drop off, % drop off. And that would tell you that we got to this point here. You might have an issue here with the spine because that's going to be all dark. And then you would do that again for this side. And then you could do the same thing horizontally to like slice it across here. Yeah, I don't love that. I don't know. It could be a good idea, assuming that's what this is. Template matching. If book layouts are consistent, use page templating. Hue line detection. Find vertical lines that separate pages, then crop accordingly. Potential improvements to your approach. Pre-filter regions by geometric properties, area, aspect ratio, extent. Use hierarchical clustering instead of k-means for more flexible cluster shapes. Apply post-processing to merge nearby bounding boxes. Consider using convex hulls instead of bounding rectangles for better text region filtering. This is interesting because I think this is what I'm doing now. So we end up with where are we? Yeah, so here we do a like convex hull. And by doing that, that is how we get, here, let's go with the better one. We get this rectangular shape. The challenge with the clustering is things like the page numbers would likely get dropped out. Like that might not make it into the cluster. I mean, especially if we're using clustering to separate by page, because the distance between the page number footer and the text is potentially similar to the distance between these pages. Same thing with the header. I mean, it would be good for getting just the text. That might help me just nail the text. But that might not help me get the header and footer. Okay. For most books, especially those with clear page separation, when dealing with varied text layouts and orientations. All right. I think I'd rather prototype this over on my other machine, where I have a good dev environment set up with Tesseract using a Python virtual environment, which was, I've had struggled to get that working on the Windows machine. So maybe I will try experimenting with this over there. And I probably won't stream that. I'll do that probably later today. I think I'll stop now, streaming now. But if this works, and I'm able to get better blocks that are just like the clustered text per page, and I'm able to nail that down pretty well. And by the way, like this one did pretty well, but actually, like see, this is bad, right? And this did reasonably well, so when I told it to crop it based on that region, or like get a bounding box, it did okay. But as you can see, it's like a little cutoff here. So then I told it, hey, like just be a little conservative and let's, you know, yes, use this bounding box, but use a little bit to the left and right. It worked for this book, held this way. But you can see like we barely got the word over here. Not the best, right? Ideally, and then actually if we go even further, here's like an even worse book. Well, this is a this image was actually captured with the VR headset. Now the lighting in the room wasn't particularly bright. Like there was a light source over here, so this wasn't the best. But here you can see like, yeah, so it detected those, but the clustering Like when it tried to put a bounding box around them, this is what it came up with. And I was like, okay, let's shoehorn it. Let's do our best we can. Kinda, it did crop reasonably well. My hope is to do better than this, right? So it doesn't matter what the box is, like, doesn't matter what how the book is held. It should do a good job of drawing a box around each page. And then I can then crop that, deskew, dewarp, and then go from there. So that's kind of my hope with this approach, is like this version of the code works. This works, but this is fragile. And my hope would be to make it less fragile. And if I can consistently get a bounding box of just pages of text, then maybe like the other work that I did today would bear real good fruit. If I can, because I got the deskew, dewarp effectively working as well. Yeah, I can start building out this pipeline and actually get some good quality out of it. So that's kind of what I'm hoping for. So I guess that's what I'll be doing is detect text, which I know we already can do, bounding box for clusters, then do cropping, and then do the work that we did today, which is the merge blending of multiple frames. And if that starts looking really good, then we bring in the dewarp, deskew. If that's looking really good, then maybe we consider do some denoising, whatever. Or we, I'll probably skip this at first and go right to binarization using Gaussian filtering plus Otsu. And if that's looking really good, I'll rescale it because I know like it does want. I'll probably skip this though and just go right to OCR. But then when when I'll see like, oh, if it's only like 95% good, okay, then let's look at rescaling. Okay, check it again. Okay, then let's do some denoising and other stuff. My hope would be like do as few of these steps as possible. But I definitely think the bounding box and cropping is essential for performance, especially because if I can crop it down, that is how we will get the performance speed. As we are then able to like just then chop, like I'll probably crop it down to the page, but then I'll probably crop it from there even further. Cropping for performance speed at that point. That's a whole other thing. But that would be like, hey, let me chop it into thirds, but instead of exact thirds, because we might end up accidentally chopping on the middle of a line by accident, I'd probably cut it into thirds, but chop it into fourths or something like that, or fifths and fourths, or sixths and fifths, something like that. So that way there's some overlap, right? So then the same line of text might show up between two blocks, but then I can use that to... I probably would want that intentionally, right? Yeah, because then we can more easily stitch it together. But that's more advanced. All right, so I think I'm going to give it a stop there. Go grab some lunch. Thank you for hanging with me. I'm still in this state where I'm not sure this is going to work, but I'm feeling cautiously optimistic that it will. And I feel like I can just build out this pipeline now. And, whether this works or not, even if this fails, I think I'd be willing to say that I could put this on the shelf, knowing that this pipeline is there and maybe the pipeline just doesn't work as well as I'd like. And let me get this implemented, hopefully within the next week, get this whole thing built out. And then hopefully move on from C++ code and get back into Godot and actually just start building out the 3D environment and start doing some stuff there. So hopefully that's where I'm headed to. Again, thank you for hanging with me, and we will talk soon.